We are back live. Hi. I figured I'd come back for, let's say, another hour and a half. And we will just keep on going with this refactor. We'll see how much progress we make. I was expecting to spend all day tomorrow on this, but you know, maybe we get a little farther than that. And we'll actually be able to start evaluating like the new features and things on the experiment side, and we'll have most of the cleanup done either tonight or by pretty early tomorrow. That would be a pretty good outcome. Believe we had it working. No, we did not. What was I doing right before I left? Losses, right. Losses items. We can just add a dummy for that. No biggie. Didn't we have losses up here? So we have self losses. I think we'll move that a little bit, right? We'll just do this as losses. Okay, and then the next little piece here. We have to update this, which is a little annoying. We do get to get rid of this zeroing function. We're under 1,400 lines. Good. So that runs again. Does explain variance work? Seems like it does for now. So we can add that back in. And then generally, I guess we just start going through. We start going through the train function. So P30 is the big one that we're not doing just yet. Compute puff advantage. Takes a lot of arguments. A lot of arguments indeed. Let's focus on the rest of this. So train copy. And then you call sample. Train misc. It's a little silly. Put this into forward. Sample logits. Then we go to train MISC. We have Diane. We're still looking at. We've got some reshape logic. Variance.ratio. We need to experiment with this. Do this if we are KL clipping. Okay, so there is some KL stuff to be saved potentially. Use vtrace or use puff advantage. We have to recompute trajectory segments. Why do we have to recompute trajectory segments? Hang on, does this make sense? I don't think it does. We haven't stepped the policy yet. I'm just going to go through and label stuff like this because, you know, it's a bit late for me to be really thinking about things like this, but I can at least like start. I say it's late at 7 p.m., but hey, I go to bed before 10. Prioritize replay. And then you get your policy loss. This is clean RL. It's all clean RL. I think we're going to want clipped losses like always, pretty much. Get our precision here. Put that there. I guess it makes sense to count this. Gradient variance wasn't particularly useful. We definitely aren't doing this with it. I can just do losses of gradient variance, right? I multiply by the mini batch size. Is this screwed up because the gradients are already averaged? That might be screwed up because gradients are already averaged. We're going to get rid of this for now. Okay, and then we have the KL target, which we don't use. It seems like we probably should consider using it. Maybe. And then reprioritize experience happens at the end here. Max uses, mean uses. We may or may not need these. Our scheduler, P30. Plain variance. Mean and log. That wasn't being used anywhere. Get a few more lines out. Got our accumulation mini batches. And actually, I think that we need to, don't we? Yeah, these losses can get tabbed in, can't they? Train misc. We can tab all that in. And then at the bottom here, maybe a few small things. A few small things to modify. But really not very much. Not very much at all. So the main things that I see, whether we keep off policy at all, that seems more speculative for future stuff. Maybe it doesn't have to be in this version. Reprioritization, maybe I can figure that out right now. Maybe I can figure out reprioritization. So what is going on here? You sample this batch, right? I think it was the importance ratio. Ratio here, right? Okay, so you say that you get this new ratio. I'm confused as to why this changed. It's new log prob minus batch log probs, right? Experience.ratio. Hang on. Watched your videos on PufferLib, and if I recall, PufferLib is like a data pipeline from RL environments to models to really streamline RL. We do a lot of stuff. We have ultra-fast reinforcement learning environments for testing and research, and also for iterative prototyping in industry. We have very nice low-level tools like fast multiprocessing, fast vectorization. We've got like this native way to do that makes it really easy to develop reinforcement learning libraries in C or reinforcement learning environments in C and make them very, very fast. We have a very high performance, very low overhead trainer that is quite simple to use. We have integrations with optimizer enhancements, advantage filtering, new little algorithmic tidbits. So really, I mean, this is a comprehensive effort to just make reinforcement learning sane, simple, and easy. How could these have changed at all? Oh, it's because you only get, hang on, you only get updates on the samples that you run, right? Okay. Okay, wow, that's a lot. Feels like it should be focused for every RL library and framework. Make training as fast as possible and data efficient as possible. I honestly, the rest of RL is just trolling right now. Like, it's been since like clean RL, since anybody has done anything reasonable in this space. We're going to change that, and we are changing it very quickly. I mean, we have training running like anywhere from 500,000 to 3 million steps per second for reasonable policies. We can run tens of billions of experiments per day on a single GPU. We have a ton of different environments that we use for research. We've got a nice open source community of people building stuff. Our code is way simpler than libraries that are 100x slower. So I mean, really, this is where I'm placing my bet on making RL work. It started off like, yeah, we're going to build some low-level tools and we're going to integrate with all the other libraries, and it's going to be like, you know, just a small thing. But now it's really, we are going to fix everything that's wrong with this field. Like, this train file has almost 0 dependencies, and it's currently under 1,400 lines for everything. And we're going to try to get this thing even shorter. So like, my goal would be to have something that's close to 1,000 lines that just solves everything basically out of the box. A few extra tidbits not included in there, mind you, but like, that's all of the algorithm. That's all like the experience buffer. That's like pretty much everything other than like models, environments, and then I think there's hyperparam sweep stuff that's outside of this as well. And the hyperparam stuff is probably going to stay outside of here. Other than that, though, pretty short. Did I not solve this by moving the advantage computation down? Something very odd about this. So, you need this ratio to know what to sample. I don't like that I have like two separate places where I have to do all this advantage calculation stuff. I mean, I can make it much shorter, but still. It's like confusing. I'm computing the advantage on literally everything here. And what are we sampling based on here? Importance equals advantages. We're sampling based on importance, which is advantages. And where's this ratio? Variance.ratio. I think this gets set. Yeah, so this is going to start out as 1. I mean, you ideally want this term to be fresh, because this is the v-trace part of our advantage estimation. Really excited to try it. Amount of tedious work trying to write different RL setups for each and every different problem is incredibly annoying and scales horribly. You really should try some of this stuff out. Then, like, we got a nice community over on discord.gg/puffer, and you know the dev branch is not going to be as stable as the main branch, but I will say that we've pretty much just set soda on everything we've thrown this at on dev, almost out of the box. It feels like a different field on this code versus like our 2.0 release. Like, we have a different field. Like here, this is an experiment that I have running right here. What are we at? Okay. This is making some progress. So this x-axis is in tens of billions of steps. So this here is like 2,000 years worth of gameplay. And this is on Neural MMO 3. This is not a toy M. This is like way more interesting than the vast majority of stuff in academia and a lot of the stuff in industry. And you can literally just go to Puffer AI and play it right here. You can watch some bots run around. You can like see different agents doing stuff. They're scripted agents, but they're also neural like trained agents. And they like buy and sell stuff. They fight. They collect resources. They get equipment and stuff. And that's just one of our benchmarks. And that environment runs at 1.5 million steps per second on a single CPU core. So, I mean, it's just like orders and orders of magnitude faster than everything else out there. And you'd think, oh, it must be really complicated, but it's not. It's like simpler than what's out there as well. Is it all written in C? Just the environments are in C. Environments, and now we have like one CUDA extension for one thing, like an advantage function. But the training code's all just PyTorch. It's nicely optimized PyTorch. It's got really large batch sizes and stuff like that to help it out, and we've cut overhead in a number of places. But yeah, the environments are just in C. There's optimized vectorization. The vectorization's in Python, but it's optimized so that like everything writes into shared memory without having to do a bunch of redundant copies. And I mean, the env code is actually very readable as well. So like, let's say you want to go play around with Neural MMO and like do something with this environment or any of the other ones that we have here in the on the demo. I mean, we have tons of different things, everything from Breakout up to that. Let's go here, PufferLib, Ocean. Ocean's our first party M's. And here's all the code. 2,800 some odd lines. This is pretty much all the code for Neural MMO. It's just one file. And if you just scroll through and read this, it's literally like first year undergrad level C. It's intentionally very, very simple. Like if you've taken one systems course, like any course whatsoever taught in C or C++, you can like read this. And that's the way we intend to keep it. Okay, so it is actually necessary to recompute the advantage the way I'm doing it, because the policy is going to change, and then you have a new policy, and then you need this new ratio term. Yeah. So you do need to call it twice. Once for sampling. To be fair, you could use a different metric for sampling, one that would be easier to compute. But it makes sense to use the advantage function. This will get simpler though if we get rid of the alternatives. Like if it's just this, it'll just be this one line. Yeah, so the main savings in here, it's going to be P30, and a few other things. Okay. We can look at store next, maybe. I'm in a situation where I'd like to use RL port, but I'm figuring out how much of the code base I'll need to rewrite in C. So you can technically write puffer ems in Python, and we have cases where we still train, like, I think 100 to 200x faster than other libraries, even in Python. I mean, the C is really nice, but it's not necessarily required. C++ and rewrote it in JavaScript. I mean, if you can bind it to Python, you can leave it like that. You can also do C++, to be honest. We just, in our M's, like the M's we ship with PufferLib, we use C because I don't like dealing with C++. But like, here, let me show you. You have two options for this. The one that's in 2.0 right now is just, we write a random Python intermediary. So like for something like Pong, it's this little like binding file, not that little, it's 100 some odd lines. And it's just, you have to redefine the header basically. And then you have this little init function that just wraps the environment creation in Python, which then runs multiple copies of it and it compiles to C. And then in dev, the other option, which is quite a bit simpler, is you just write a little binding file like this. And you just say that, okay, we're going to have functions like C step, C reset, whatever. You just follow like a very basic little API, and then you just define a couple functions to tell you how to convert arguments from Python to C, and then also what log data you want to get back from C, and then it's done. And this just uses the Python C API, which I believe should work fine with C++ as well. Like you can mix and match if you want. We choose not to because we don't like dealing with C++ in our first party M's. I have to rewrite some of the performance critical code currently in JavaScript and C or C++. Well, it's really not going to be that hard, is what I'll say. Like with the way we do stuff in Puffer, it's really not that hard to write custom M's. And like you have a dozen different environments that you can go read and see how we've done them. And you've got a helpful community on the Discord to help you out when you get stuck. And you can always bother me on stream with questions as well, because that's kind of why I stream, right? Some people watch just for like, cool, let's see what programming is happening, but also we have people that watch to like come drop by with questions about Puffer. So this is always going to be the case now that I fix this. So this is actually kind of convenient, right? We can always guarantee we have a contiguous set. We can do this. Ideally, we get it so we really only support one major code path. And it's just the best code path. You know, I'd rather, instead of having like all toggleable features, I'd rather just have one code path, like one feature set that is just the best feature set. Okay, this mean and log makes sense. Okay, so a few more things to fix up over there, for sure. But we are now at 1368 lines. That's like minus, what, 150 today? With all the new stuff? Pretty good. I'm trying to think. I'd like to keep doing some stuff for the next 45 minutes. I'm pretty tired, though. I gotta find something simple I can work on here. Let me see if anybody's bugging me on Discord for stuff. I had to just cancel that live monthly meeting. Nobody wants stuff for once today. Cool. That's like the one day I'd actually looking for something simple to do. Well, I'll just find something to optimize here. Why don't we get performance numbers back in? That would be good. And do profile.elapsed. Is it just D items? Yeah, it is. Hmm. I think I did it wrong. Try this. How are you supposed to do this thing? Ah. Does it need all this? I think you literally have to add a dot. Yeah, you have to add a dot items, obviously, right? Let's do it this way. This is how I did it before, right? With iter. There we are. So now we have our profile numbers back. We're missing SPS. So Why don't I just add this? Yeah, you can't really even do this here, can you? I'm gonna have to do that tomorrow. I'm actually getting pretty tired. Because I don't know how I want to like restructure this right yet. But we did get the performance metrics back on. Do we still solve breakout? Or did I break something? No, we still solve breakout, alright. Do rollouts real quick. This runs, right? Console.clear. This is hard-coded for now. I gotta make an arg for that. Definitely need to do the frame saving. Should still work, right? Yeah, it still works. How do you add an artifact to Neptune? How old is this blog post? Where's their frickin' API reference? Like, what? Okay, so I guess they like just don't have docks here anymore, so I'm gonna have to migrate up. Hmm. Let's play with a couple things in the meantime, right? let's just start on the thing I want to do in the morning tomorrow. So, the first thing I wanted to do in the morning was to try like a value function distribution kind of a deal. So the idea here is that you discretize the value function. Yeah, the idea here is you discretize the value function, and then you do cross entropy on it instead of having to do. Oh shoot, but that's gonna mess up advantage completely, isn't it? How do you deal with that? I'm trying to think how you would do this. Do they have a function for this in the distributional Q-learning paper? Or do they not have an advantage function in here? I guess we just do like some softmax thing, right? Where's the softmax in this? I torch log softmax. But it's log of softmax. It should just be softmax. That doesn't seem right either. There we go. It got dark and I didn't bother to turn the light on. Hey, Bet. Do I have a light here? Yeah, I do. Oh, that's real bright. There we go. We actually do have decent lighting. Huh. More you know. Yeah, we got torch to work. It was hell. I'm messing around with some distributional stuff at the moment. Went to the eye doctor and they were critical of me never buying new frames. Isn't that a Gandhi thing? That's straight up a Gandhi thing right there, you did. You have to go train it. Yes. I'm kind of just hacking on this at the moment to get something to something to work. Okay, so now we can do the loss function. Oh, you're supposed to predict returns, not rewards. We can fix that. Hello, that guy. Advantages plus values. Yeah, it's bash as in he bashed his keyboard. I think I want to do this. Cute puff advantage. Gonna have to redo it, don't you? Not all of it. You go right here. Oh no, you don't have to repeat like any of this actually. Because what you're gonna do is quite different. Okay, I think I get it. So we do rewards. So we just do like disk ret. Or norm ret. don't think, is there a better way to do this? Oh wait, they gave me a formula for it, didn't they? They just do max minus min. Okay, we can totally do that. But wait, how do you do... You just define a value max and a value min. I see. Man, I'm kind of too tired to think about how to do this right now. I think I'm going to have to start fresh with the proper formula of this. Basically, I want to discretize the values into buckets and have that play nicely with the advantage function. But I've been doing this all day, so I'm going to start fresh in the morning. The point of this is just to see like if there's anything there initially. If it instantly works, then great. You know, we'll know that we can include something like that, and then P3O is going to be probably not needed on top of that. But yeah, I don't know. I'll be back all day tomorrow. All my stuff's at puffer.ai. If you want to help the project out for free, start the GitHub. If you want to get involved with dev, join the Discord, discord.gg/puffer. If you'd like, you can follow me on X for more RL content. So, thanks, and I will see you around.